So let's combine array and file together to form a new data set. The question asks you to create a program to count the word's length distribution of a text file. For example, if you have Mary has a little lamb, little lamb, the first thing to do is to reading the file row by row, and then it will split the row into words or tokens, assuming there's no punctuation. So after this transformation, this Mary has a little lamb, little lamb. Let me copy this over. Will become Mary has a little lamb, and little lamb. This is the token. This is a token list. Then the program should count the number of strings of a certain length, which means you will count the length of each and every word. Mary is 4, has 3, A is 1, little is 6, followed by 4, and 6, another 4, another 6, and another 4. So that's the token length, the word length you get. This is one of another token conversion that we talked about. Now we need to count how many 4s are there. There are 4 4s and 3 6. So the end result will be length 1, 2, 3. There's no length of 2, so it's just length 1 and 3 and 4 and 6. Now reading the file and parsing the file and even getting the length are things that we have done before, right? So there's no need to just to discuss how to achieve this. The question will be, how do you save this length information? And we will save this information in the array. So it will be an array of word length count. So for word length count of 1, of course, the array will first initialize, all elements will first be initialized to 0. So array length 1 will be 0 first. Then once we see there's an A, we will add a 1. For array length count 4, which means the total count of words with a length of 4. Initially, it will be 0. Once we see there's a Mary, it's a 4, we will add 1 to it. Then we see a lamb, we will add another 1 to it, and another lamb, 3, and finally last one, and 4. So this is how you calculate it. And basically, as you can see, it will be the string dot length. String dot length subscript. The string dot length will be the subscript of the processing, and we will just do a plus, right, for each word. Now the question will become, so we're here with count. This means for each word, string length count. The question will be, what's the size of this word length count? Here we can use the partially filled length idea, because everything is initialized to 0. So if it's 0, then that means there's no such a word length. Because of this, we can actually set up an upper limit where no word will ever have that length. I think 100 should be enough, right? So if we set up a word length count 100, the 100th element, which is word length 99, will only get accessed when there is a token that is 99 characters long. And I don't think there's such an English word. I think the longest probably be 20 something. So we will define a word length count of 100. And for each word, we will break up, we will read the row by row, we will read the file row by row and break it up into words. And for each word, we will count the string, and we will add 1 to the word length count to the string length count, string length position of element of that word length count. So let's create a program. Sample question file word length count. And I'm going to create a Java doc. Copy this over. Now we can actually copy a lot from previous previous code. So I believe in assignment 4, we have the assignment 3, we have the file reading, read and write. So we are going to start by create scanner, get input. Let me copy this all over. We do not need the output file here. So I'm going to remove the file output side. Output file, and now you can see the good, what's good about having blank space in between code blocks. You can immediately identify where each code exists, right? And I think I forgot to, I'm sorry, I think I forgot to add the public static void main. String array args. And now let's copy this over. And you can immediately see what's good about having code written in block separated by blank space, blank lines. So you can immediately spot this part is about output file. So we will just remove it. And this output file, we don't need it anymore. Remove it and output. This does makes coding much easier, right? Of course, here we need to import. I believe that's the reason we have an error. We need to import from utility. Oh, we do have the import utility, but we don't have that throw exception. So let's copy this over too. And as we copy over, these two are already also get populated by Eclipse automatically. So now we are reading each file. Once we read this input line, we are going to parse it by the same way as we do in our sample code here, string parsing. So int, here it will be a string tokens. But this time, we are going to split by space, right? Now we have a string of tokens. We will add them to, we'll convert this, we will get the length and perform this for each string. Right, so it's a for int I equals to 0, I less than tokens dot length, and I plus plus. And then we will do this for count string length, not string length, but the token I. And now we need to define this word length, which is a integer array. We will call it a new int 100. As we discussed before, there shouldn't be any word that has a length longer than 99. So 100 should be enough, right? So this is the word we have. This is the code we have. If you are not sure, what you can do is you can, before you do the processing, you can just do a system dot out dot println token, so that you can see that there's nothing wrong with the token. So I'm going to input a file name. I actually have a file generated before, and you can see there's. So let's try use this file. Input. And you can see it is being broken down properly. Now let's do the word processing. And of course, I forgot we should print out. I think we also need to print out this word length count. So I'm going to do is print from 0 to, of course, we know the length is 100, but usually it's recommended that we use the array name dot length instead of using a fixed number. So it will be system word length I. But of course, we can make it better by making an if statement. If not equals to or greater than 0, then we will do the print. Class. And here's word length. Let's put input.txt. So we have quite a few of 1 and 2 and 3 and 5 and 7, which 5 is actually prime and 7 is a number. And the 1, 2 is probably the numbers that we have in the prime number discovery process.